All right, calculus. We're going to have a test tomorrow, so I'll let you study most of the time. So I just want to add a little bit to, sounds like the door alarm. I'm going to add a little bit to our discussion on the derivative. So just make a tiny bit of forward progress. So if you would just take notes on this, and we'll be looking at it more on Thursday. So this is the Tuesday night edition, and that's the 27th. You'll be watching it after Tuesday's class at some point. So we learned that the limit as h approaches 0 of f of x plus h minus f of x divided by h. It used to be the difference quotient when we just had it like this. But now when we've added the limit, we get a derivative. And it turns out a derivative is no more than the slope of a tangent line to a curve at a given point. I wanted to make note that your book, and many others as well, probably more than I've seen like this, use a slightly different notation. So what they're thinking of is they're looking at a graph. Here's the picture. Say we want to get the slope of the curve at this point. I'll just put that in lightly. So initially we go for the secant, and the secant, we start with another point on the graph, and we draw a line that connects those 2 points. And this is the secant, and what we did last night is we called this value x and this value x plus h. So we go up from x and find x plus h, and then we found that this is f of x plus h and this value is f of x. So if we were doing a rise over run, this would be f of x plus h minus f of x. And this would be x plus h minus x, which is just h. So that's how we did it yesterday. What a lot of books tend to do is they replace that h with a different symbol. And they think of this as x plus change in x. Change in is a little triangle. We use it freely now, so be comfortable with it. Change of x, so this is called change of x. So in here, this is change in x. This is change in x. So the derivative is going to be the limit as change in x approaches 0 of f of x plus change of x minus f of x over change of x. So that is the more common symbolism used in the derivative. However, it doesn't fit very well in our song. So I've also seen h used quite a lot as well. All right, just some details about the derivative. We call it, say we're finding the derivative of a function, we call it f prime of x. So that's the symbol that we use for the derivative. F prime of x equals this limit. So there's some others. So f prime of x is often used, and you'll be familiar with that. Dy dx is another one, and that is the derivative of the function y with respect to x. Derivative of function y with respect to x. This with respect to x tells me what the independent variable is in the problem. So often it's x that we're happy using functional derivative notation that doesn't even mention what the variable is. So, but this one is clear, because sometimes, a lot of times in real life, we're using time as the variable, the independent variable. So we would have dy dt. But we could have dx, dy. There's a lot of different possibilities. But for now, the most common and the one I want you to be aware of is the derivative of the function y with respect to x. It's read dy dx. Dy dx, sometimes we write this as y prime, so we could change the f of x to y and call it y prime. Less commonly, but not unheard of, the derivative of the function f of x with respect to x. And lastly, this one. All right. You will be very, very comfortable with this one and this one mostly. But the others, you will see, will have their day in the sun. Some of them are just better for different situations. All right, we'll end tonight with this idea, and that is there's another form of the derivative. So basically, changing h to change of x symbol didn't really change anything. But now I'm going to show you a totally different expression for the derivative that is sometimes quite helpful. So, all right, so let's draw in our graph. We're looking for the slope right there, and we're going to use the secant to help us, and we're going to shrink that change in from here to here, and as the point goes closer and closer, the secant becomes a tangent. So, let me see if that's a little too high there. All right, I think that's in. All right, let me just pan back a few seconds. All right. And hold on to your head. All right. I don't know. I'll try it there. All right, so I'm going to look at the alternative definition for derivative, and that'll be all. What we can do sometimes is we call this value c, and then we go up from it a value, and we call that x. So c is from here to here, x is from here to here. So likewise, if we go up and hit the point, we get f of c. And if we go up to from x, we call this f of x. So this time when we do our slope of the secant, we're going to get the rise to be f of x minus f of c. And we're going to get the distance along the horizontal as x minus c. So as what's going to happen for our limit here? So we're going to have f of x is the rise over the run, and the run is going to be x minus c. But what do you think, what limit am I going to take up when I'm looking at it from this perspective? The limit as what approaches what? Well, what we're going to do is we're going to shrink this again, just like the same idea as this one over here. But the way we do that is this value x is going to approach this value c. So we're going to take the limit as x approaches c. So this is a totally different form with a totally same concept. So if you would write down that second form of a derivative, it is sometimes helpful. So, all right. So that's all I wanted to say for tonight. Made a little forward progress. Study, this is not on your test, but study from the first chapter. This is going on a little bit into the second. All right, do me proud tomorrow, and I will see you at test time. Till then, bye-bye.